Oh God, oh God! Just gotta get our trig subbed. But first, we need a game plan. A game plan. Choose the appropriate sub. That's step 1. Step 2, make a sub and don't forget dx. Then what? We're gonna do all the algebra and integrate. After that, it's a triangle in back sub. How do you choose the appropriate sub? You're using trig sub when you have roots. So, we're getting all radical on this. What do I mean? If you have a squared minus x squared underneath your root, then you choose x to be a sine theta. If you have a squared plus x squared, you choose x is a tangent theta. If you have the square root and it's x squared minus a squared, then you choose a secant theta. Why? Because it performs these identities. Bam. Well, it's going to make those identities, and you're going to rid yourself of the root. You're going to get down to the root of the problem. Root. Let's see an example. Boom. Here we go. This is a nice one. Oh, not entry level. It's definite. So we definitely have dx over a squared plus x squared to the 3/2. The 3/2 indicate that you have roots because it's a rational exponent. But what? They also told us that our a is bigger than 0, but that doesn't come in now, that comes in later. So we need to choose our appropriate sub, and what would that be? Boom, boom, boom. A tangent theta, then what? You're going to make the substitutions, but you don't want to forget dx. And that's what we do here, because the derivative of the tangent of theta is the secant squared theta, and a is just a constant, so we just leave him out. So now we throw everything in, bam! Our dx was a secant squared theta d theta, and then where I saw an x down there, I get a squared tangent squared, because when we square a tangent theta, it's a squared tangent squared. Now, we do the algebra. We slip an a squared out. That right there is all still to the 3/2 power. Bam! So I do this, make it rain, and when I do that, I end up with a secant squared theta d theta. That's a squared to the 3/2 secant squared to the 3/2. What I do? I busted a trig identity. 1 plus the tangent squared was the secant squared. Then its properties of exponents. Boom, boom. That's how we got the 3's there. Now we simplify with e's there. Up here, I'm going to take it to the top. And we have d theta is over a squared secant. Whoa. Where did my third go? Oh, the secant reduced. I see. Can't. I can pull that constant out of the integral, and then 1 over the secant is cosine theta. So our nasty turned into nicey. And I see. I integrate the cosine to be sine. And then I'm going to take this and make some room. I'm rewriting it. Because why? Now I'm on to step 4, triangle and back sub. Oh, it's like MMA. We just busted a triangle. After, we get the tangent theta to be written as x over a. So, the tangent is opposite over adjacent, and we use the Pythagorean formula. Yeah, that's right. The Pythagorean to get our hypotenuse. Now what? We go back to the sine of theta, and we need to read the sine off of our triangle. The sine is the adjacent over the hypotenuse, and then that's why I write the adjacent over the hypotenuse in place of sine. But we definitely don't want to forget that they originally gave us a definite integral. So let's evaluate that with the fundamental theorem of calculus. That's the upper minus the lower. What's upper? I put an a everywhere I see an x. Then, since I have that x on top, that's why that second part is 0, this part right here. And then in the bottom, of course, we would have like a to the third, but who cares? Clean that up. Did it. Finish him. Yeah. Box and flour.